Hi everyone, Engineer Liu here. So it's time we finalize covering most of the string.h functions, the most utilized ones at least. So we covered string length, string copy, string concatenation, as well as string copy, string concatenation, and string compare. Yeah, that were the ones that we covered. We also covered how to write your own string functions, and we show that most of them from the standard library are unsafe to use. Also, we ask ChatGPT to write one for us, which were safe, right? And now let's take a look again at the manual. And there are some which, to be honest with you, I have never used in my career as a developer. So I will cover the ones that I use the most and the ones that I feel are most relevant to you as a C developer. So the next ones we can take a look is this one right here, which are very similar but they're used a little bit different, which are string char and then string string. Okay, so the string char returns a pointer to the last occurrence of the character C in the string. Okay, so yeah, it's usually useful for checking if your string contains a certain char, and then you're parsing data, and there are several applications for this. And there's also this one that is very useful, which finds the occurrence of a string inside a string, like a substring. Okay, so we string it finds the first occurrence of substring needle in the string haystack, returning a pointer to the found substring, unless it is returns null. Okay, so yeah, let's go with our standard procedure of writing a C program. So standard IO, string.h as headers files, the libraries we want to use, int main. By now, as you have seen in the last video, we will use the arguments for the main function, which are command line arguments that can be very useful. But I guess for this video we won't be using, but we can use, so we'll see about that. But get used to write your main function like this, so you can accept and handle command line arguments. Okay, so just to recap, argc is the number of arguments, and each argv from its index from 0, 1, 2, 3, 4. Each one is one command line argument. The 0 is the name of the binary itself that you're executing, and then the other ones are the arguments that it may pass, which could be a number, a string, and so on. So okay, let's get to the main topic here. String checking for char and string, and checking for string and string. So last string we will be working with. Let's call it a string like this, and then it will be strings. Just a reminder for you all, because I like to keep repeating myself on such important topic. Strings in C can get you hacked. So let's leave it. Strings in general. Strings can get you hacked. Okay, so that will be the string that we want to mess around a little bit, right? So let's check first if this string contains a certain character. Okay, so if string char string, and the character we want to look at is remember, if we're dealing with char in C, you have to use one quotation mark, and here you can, for strings you have to use 2 quotation marks, so that's this detail, otherwise it would raise error. So if this is different than null pointer, then we can say string contains the char asterisk. Okay, we can use like this. And let's check for another char if string char string as char that is not okay, so we can use at, like at is different than is equal to null. That means it doesn't contain this char. Print f string does not contain the char at. Okay, so oops, I made a typo over here. Okay, so we compile and run. Warnings, and okay, as expected, we obtain the string contains the char exclamation mark, and the string does not contain the char at. So this is useful, for example, you're doing a validation of a field, like you're developing a web server, and then let's say, of course you will probably use the regex for something like this, but let's say you have a field that is you're checking for if it is a valid email field, right? So email must contain this char here, over here, and then use this function over here, and to check if it is a valid field, and then you can perform validation, right? So the other function that is pretty similar is you can check for a whole string if it contains a whole string. So let me show you. So it's a string, and then we have the string that we want to look at, and a substring. So let's see if our string contains the word the string hacked. Okay, if this is different than null, that means it contains the string. Okay, and yeah, so printf the string contains the substring hacked. Okay, so compile. Yeah, the string contains the substring hacked. Well, the thing is with this string function is that it returns a pointer to the beginning of the occurrence. Okay, so let me show you that. Let's create another string. So let's call it string 2, like this. And we can do the following. So string 2 is equal to string and hacked, and then we print f string 2 Yeah. So there we go. The thing that's interesting about string, which checks for a substring in a string, is that it returns a pointer to the occurrence of the first char that found the occurrence of the substring. So it returns a pointer beginning at here, h, okay? And then when we print it, it printed the remaining parts of the string up until it found the null terminating character, right? That's how it knows that the string has ended. So this is very useful when doing parsing, like say you are building I don't know, a compiler in C, and you're translating parsing text files or parsing data. It's pretty useful in that regard. So let's check that. So as you can see here, the string function finds the first occurrence of substring needle, which is the second argument, in the string haystack. The terminating loop bytes are not compared, so this is ignore. Return value. These functions return a pointer to the beginning of the located substring, as I was saying, or null if the substring is not found. So yeah, you can check if the string, if there's you can also use as a string char for validation of fields and that validation of data, that sort of thing. And yeah, so I guess a string char works pretty similar. So a string char returns a pointer to the first occurrence, yeah, so it also returns a pointer to the first occurrence, so you can work with it, parse data, and so on. Yeah, last occurrence. Yeah, it turns a pointer to the null byte rather than. Okay, so there's this function here which I haven't worked at all. So yeah. There's still one more function that I would like to go through before ending this series on the actually two functions that I would like to work on for ending this series. I guess it's 12 minutes now. We got plenty of time, which is sprintf and then string talk, which is for parsing tokens. So we get to that. So let's check if argc is less than 2, which means that an argument is missing. So we printf insufficient arguments provided, and then we exit the program. We simply return with status code 1, and then yeah. So the thing I want to do is take argv1, which is the first argument after the binary name, and then write it into a function, like it will be I don't know, your name. So yeah, so let's call declare a buffer. So char buffer, and let's say with 256 bytes, I guess it's enough. And before that, we also have to do some other validation, like check if it is, or argv is less or equal, the string length is less than or equal than 256, unless we have a problem. So let's define here a buffer size, so we don't have to keep repeating. So here, buffer size. So if our string length argv1, which is a string, is greater than buffer size, we abort the program, because yeah, we don't want to get hacked, remember? So we don't want buffer overruns, buffer overflows, so forth, right? And yeah, here printf, oops, the argument provided has more than 256 bytes. And then we return 1 as well. Okay, so what I want to do here is use a function called sprintf, which basically takes a buffer and then writes a string to it. It's like printing to a string, okay? And let's say hello, and it would be your name. Hello, I don't know, John Doe, like something like that. And then we can provide the arguments much in the same manner as we use for printf. So here we will be argv1, and then we can print the buffer. Okay, so that's the usage of sprintf. It's used a lot and taking arguments, and this is not a string literal and no formal arguments. Wait a second. Char string. Oh, okay, here. Not string literal, no formal arguments. Buffer. Yeah, I guess here we have to do this. Yeah. Okay, yeah, we forgot to pass the argument. So we have to pass one argument here. So I would just put my name, Leonardo. So hello, Leonardo. There we go. And yeah, that's the usage of command line arguments here. Another example besides the last video on malloc versus calloc. And yeah, so an example of usage of sprintf. So basically you're printing a string to inside another string, usually a buffer. The thing is, there's a problem with sprintf, as you may have guessed. There's always a problem regarding sprintf. So there is alternative to sprintf. There's SN sprintf, which takes a string, the buffer, and the size t of the buffer, so we avoid buffer overflows. Okay, so don't use sprintf, use SN printf. Okay, so yeah, as you may have guessed, there is this this issue. Okay, so use SN sprintf to avoid buffer overflows and getting hacked. So we compile, run, everything runs smoothly. So let's say if we got a buffer of only 8 bytes, right? Since we're using a safe version of sprintf, it will be truncated, as you can see here. So hello L, since we only had 8 bytes. Okay, so it works and it prevents us from getting hacked. It gets the job done. So let's go back to 256, and yeah, we're almost at 19 minutes, so we got plenty of time. And okay, so we are almost at the end of the functions that I wanted to talk about on this series of tutorials. I might talk about in other moments about other functions that involve string manipulation, but this one is very interesting, so let's take a look. It's called string talk, which means string token, and so basically what it does, it takes a string as an argument and then looks for a delimiter. For example, let's say you have arguments, you're parsing data, and this data is separated by, let's say, commas or dots, I don't know. So how it works is like this. So it breaks a string into a sequence of 0 or more non-empty tokens. Okay. On the first call, the string token, the string to be parsed should be specified in string. Okay, so it will be the first argument. In each subsequent call, that should parse the same string, so string must be null. Okay, so that's very important. And then returns a string. A delimiter argument specifies set of bytes, a delimited tokens in the parsed string, so it will be like a comma, a dot. Yeah, the caller may specify different strings in the delimiter. In successive calls that parse the same string, so you can use you can handle different delimiters, like if you're working with different data that should be handled differently. That might be very useful. Each call to string talk returns a pointer to a null terminated string containing the next token. This string does not include the delimiting bytes, so yeah, that makes sense. If no more tokens are found, string talk returns null. Okay, so how can we implement that? Is there return null, a sequence of calls to operate as maintain the pointer, then determine the point of which. Okay. So is there an example here? Program source, char, token, subtoken. Wow, it actually has. So yeah. This seems a little bit complicated for what we're trying to do here, so I guess we'll go with a simple example. So there's a thing that is a little bit tricky over here, which is in your subsequent call that should parse the same string, the first argument here, string must be null. Okay. And if there are no more tokens, then where is it? If no more tokens are found, string talk returns null. Okay. So yeah, let's try it out. We are on string 2. Let's call it string char string 3, right? And let's say we have Leonardo, my age, which is 34, and then my my job, which is developer, right? So the delimiter here is the comma, and then we want to separate each of these 3 main characteristics, right? And then we can use do while okay, so we can use let's say we have a buffer, let's call it buffer 2, and then buffer size, or I guess we don't need that. Let's say buffer only a pointer, because here we used string 2. Let's use like this string 4, and then okay. So do string 4 equal string toke, and then we pass string 3 and then our delimiter, which will be comma, right? So remember, this is the first call, and then while string toke and null, and then comma is different than null, which means we found all tokens, right? And then we can print at each time string for here. So yeah, this is a lot of lines here we can remove. Okay, so let's try it out. Passing argument to string token makes pointer from integer without a cast. String token. So const char delimiter. Okay, so it must be a string as well. So we use like this. Expected. Okay, we missed. We missed a semicolon. Yeah, I guess it's working properly now. And then remember, we have to pass an argument. And we got Leonardo twice. Okay, so it's different than null. Let me check if we string 3. Yeah, we need to pass null here. Oops. And then we got Leonardo twice. Let's check the manual again. So break this in sequence. No empty tokens. The first call the strings in pairs specified in string. Okay. In each subsequent call, that should parse the same string, so a string must be null. The delimiter argument specifies a set of bytes that delimit tokens on the parsed string. The caller may specify different strings in delimiter in successive calls that parse the same string. Each call to string token returns a pointer to a new terminated string containing the next token. Okay. So we call it, the string does not include the delimiting byte. If no more tokens found, returns null. Okay, so while it is not null, we keep calling it over and over. A sequence of called string token that operate on the same string maintains a pointer that determines the point for each start research for the next token. The first called string token sets is pointed to point to the first byte of the string. Start of the next token is determined by scanning forward for the next non-delimiter byte. I guess that issue here is that we are assigning more than one string for, so let's do this instead. String token string 3 and then the delimiter. Okay, I see the issue here, because yeah, we keep calling it with string 3. So let's do this different stats. So for we call, oops, let's do it different. So for I equals 0, So you have to do this in loop. Let me see its example here. If token is equal to null break token string talk. Okay, so we will need this do while string for string talk while string for is different than null. Okay, so yeah, so int I. So if int I equals 0, if I equals 0, then we do it like this. Else string for is equal to string talk null, and then the delimiter, and then we print string for and increment I. Okay, so I guess that now should work. Segmentation file, so we got this correct. Leonardo 34 developer, so we managed to separate the tokens, but for some reason we obtain a segmentation fault here. So while string for is null is different than null. So it prints yes, so at some point this will return null. So we try to print null. If string for is different than null, then we print. So let's try with that. Yeah, that was a problem. We're trying to basically print a string that was a null pointer, so that doesn't make any sense. So just to recap here, you know, a string token can be a little bit tricky, as you have seen, you may notice. So for the first iteration, we pass the string that we want to separate by its tokens, right? So this was a string, and the token, it could be a string, it could be a char. As you can see here, it passes a string, but it's actually one char is that we want to separate. Okay. And then we obtain basically at each call to string token we obtain a substring, like it would be at the first iteration we obtain Leonardo, and then for this the other iteration we pass the first argument is null, because it's already internally it's already pointing to the next token, and then the subsequent calls will keep calling null, and we assign to string 4 here. And then if it returns null, that means that no more tokens were found, and then we obtain all the data we are trying to parse here. So hopefully that made some sense. And here also I had to check that the string 4 was not null in order to didn't print it and obtain a segmentation fault here. Okay, and I use y here. Actually a variable to keep track. Okay, so regarding strings, that's pretty much it. I hope you guys liked this series of tutorials on strings. It was pretty extensive, so now I guess we can move to other topics regarding C language, such as handling files, opening files, writing to files, and things will get very interesting, and then we can think of building our own project, right? As an exercise. So hope you guys like this video. Don't forget to like, subscribe, and comment, and activate notifications as well, so you don't miss any new videos. Okay, see you next time, and bye.